This video shows you how a hybrid evolutionary computing system works, but first I'll explain what the diagram is in front of you. This problem is a dynamic problem where there's a number of peaks in the image, so this is the problem space marked in blue and then coloured as the maximum, changes colour to a maximum here. These points here are the present pool's best fitness function so far and its actual true solution. So let's explain a bit more about the problem. The problem is a dynamic problem where these peaks are set for a particular time period at this particular height. So let's say that after another time period they will actually change. And this system will then have to find the next peak in this set of peaks that move about over a certain time period. So let's just see what happens when I leave this to evolve, and then I'll explain what Hussein means, which is my PhD student, by search space partitioning, which is stated up here. So let's leave it running for a second. Now I'm going to stop now because what happened here is Hussein is telling you that the best solution so far, one of the pool solutions, has nearly achieved a very good solution considering this is the true peak here and it's nearly met that requirement. Now the other thing and what state space partitioning does is it partitions state space and then allocates some of the search items in the pool, which are these crosses, which are solutions, across the rest of the search space. So let's say that again. After a while, as we saw before, the population, 20 possible solutions, will converge to the possible peak value. Then what Hussein cleverly does is he repopulates the search space, taking a percentage of the elite values and keeping those, and then repopulating the rest of the state space and partitioning it, hopefully to evenly distribute the other points in the population pool across the search space. So let's just leave it to evolve a little bit longer and see what it does. And you'll see that it'll converge. This is maximizing diversity, by the way. And as you can see, what's happening slowly is these points are converging slowly towards the optimum value. Now I'm going to leave it running now because in a minute a new peak will appear and this one will now not be the maximum. Now we've stopped, so I'll stop it a minute and you can see what's happened here is this point is now degraded to a minimum and another maximum has appeared. So this is the dynamic problem we're trying to solve. So I'll stop there and say thank you very much for listening.